Hello, I'm going to walk you through some of the Unit 5 topics now. I find this unit for the standard videos is confusing to students. So I'm just going to walk you through it and talk you through it a little more than I do in some units. So again, I'm going to go to the YouTube playlist because it has a nice table of contents here and go over that so we can see. So as you watch the intro ones, and the first whole set is really good. Good introduction to machine learning. Unit 5 introduces machine learning and then talks about some particular types of machine learning. Particularly this.
In my own research, I've extensively used machine learning for robotics. What you see here is a robot my students and I built at Stanford called Stanley.
So the Stanley introduction is great. So again, the first set, this videos, and then this taxonomy gives you a good overview of machine learning and what are the different topics and terms in machine learning. In fact, I've highlighted those down here. So the topics he goes over are just highlighted. Parameters, structure, hidden concepts, what are we learning, supervised, unsupervised, and reinforcement. Just a note, this week we'll be doing supervised learning. In the next unit we'll be doing unsupervised learning, and then the following unit we'll be doing reinforcement learning. So we'll be spending a unit on each of these areas. So he just lays out a good overview of this sort of idea. And again, a little introduction to what classification and regressions. We'll be talking a lot about classifications, taking some data and trying to figure out what class of problems this is. This could be speech recognition, taking a speech input and classifying it as a word. Could be vision input, taking an image of something and then trying to classify what it is. So there's lots of classification examples we'll be looking at. Okay, back to the Stanford video. So again, the first 5 are all great. Introduction to supervised learning is good. Occam's razor is a nice concept to get introduced here. It really fits in a wide range of things, not just machine learning. And then get down to the 8th video on spam detection.
So really important example of machine.
Sebastian walks you through an example of spam filtering. This used, I don't know if you see this as much in our email boxes, and it used to be more common 10 years ago. We get lots of spam email, and a common way of filtering these out was something called Bayes network. And when a mail came in, you'd have to mark it as spam or not spam. Sebastian uses the term ham for that. And this is the example he uses throughout here, so make sure you watch 8, which is the introduction to this. Then he walks you through a series of examples here, and they get into a fair amount of statistics, which might be confusing to some of you, including down here where he talks about Bayes.
By now you might have recognized what we're really building up is a Bayes network.
And he builds up the math of a Bayes network. And again, for some of you who don't have a strong statistical background, this might be a little bit challenging. So I'm going to just walk you through some of this stuff that he does in these lectures down through about year number 27, where he summarizes Bayes networks. So let's just go here, back to the lectures here. And I'm going to look at the spam filtering example. So here's the spam filtering example, and this is the same one Sebastian walks through in the videos. So again, we're assuming we have a set of emails that are either spam or ham. They consist of a series of words, which we're not going to worry about the order, so we might talk about just a bag of words here. So here's our emails. We have 8 emails. 3 of them are spams. Offer is secret. These are really short emails in our sample. Click secret link, secret sports link. And these are ham. These are good emails. Sports is today, secret sport event, that sort of stuff. So in our little toy example here, these are good and these are bad. So we can quickly calculate some simple probabilities. What is the probability given 8 email messages that one of them is spam? Well, 3 of the 8 were spam, so that probability is 3/8. The probability, and we'll write that P and then of spam. And the probability of a new message being ham is 5 out of 8 messages so far are ham. So this is kind of what we talk about as our training data or supervised data. We've got information that is already labeled, and we're going to use that to learn from in this machine learning. So again, now we're going to use Bayes' rule, and I'm not going to go over too much of that, but we're going to use that to determine the probability to determine if a word is spam given a word in the email. So we write this out, this probability, conditional probability of something given something else. So if we're given some word in our email, what's the probability of it being spam? Now we do, from our email, we can calculate a bunch of other things. We can calculate the opposite conditional probability. Given a spam message, what's the probability of a word being in it? We can look up here and say, so here, in fact, we see link is in 2 of these 3 words. So the probability given a spam message that will contain the word link is 2/3 for that. So we've created this big table here and calculated all these probabilities. We wrote out all the words in the spam messages and all the words in the non-spam messages. So the word link occurs twice out of these 9 letters. 9 words. So the probability of link occurring being a spam word is 2/9 here. So we count up all the words we have and then figure out which percent of them are spam. I think I said the previous one wrong because I was counting email messages. We really need to count words here. Similarly, for all the words in the ham messages, for example, money occurs once, and there are 15 words that are marked in the ham message. So the probability of money being in a ham message is 1/15, or money being in a ham, given one ham word, the probability of being money is 1/15. So we work this all out, all these probabilities out. So we know the probability of spam, we know the probability of ham, and then we know these conditional probabilities. Now we can apply Bayes' formula. So given a word like sports, what is the probability that it's spam? And we can work out this law probability here using Bayes' formula. And I won't go into that too much, but it's just this probability, it's the opposite conditional probability here, and the probability of spam. So again, we can look that up right up here. What's the probability of sports given a spam word? So that's right here, that's 1/9. So this term here is 1/9. What's the probability of spam? That's 3/8. So I can put that in here. And then down here we repeat that same probability, the probability of sports given spam, and again that's 1/9 times the probability of spam, that's 3/8. So I can fill in those values here. And then the probability of sports given ham, and sports actually appears lots of times in ham messages, so that's probability 5/15, and the probability of ham here, which is 5/8. So I can fill that in and do my entire calculation and figure out what the probability of a message being spam if it includes a single word, sports. So when I plug in these probabilities in here and run this calculation, I get a probability of 0.067 for the probability of a message being spam given sports, which is a really low probability, which makes sense because most of the time when we see the word sports, it's in a ham message. So 0.067 probability is a nice, a good low probability. Okay, I'm just going to jump back up then to these Stanford lectures. So again, we've gone through all this stuff on Bayes network and spam detections, and we're not going to cover those in too much detail. So again, just go over them quickly and try to understand the basic concepts of these spam filters. If you have a little bit of if you can follow the statistics, it's rather interesting. But if you can't, that's fine. Keep going, work your way through it, and get down here to the regression stuff. So next he talks about his linear regression and how that applies I'm going to jump into this example, linear regression.
Now, obviously, you can answer this question without understanding anything about regression. But what you
And he talks about curve fitting of a set of data. So again, we have a set of known data, and then we're going to classify or predict some future data. And what he has is an interesting graph from his area of house prices depending on the house size. And then the bigger the house, the more expensive it is. It's interesting to note that his smallest houses start at around $300,000 to $400,000, and they're less than 1,000 square feet. So I have a student moving out to California to San Francisco this spring. So just to show you, here's the graph. Here's his graph here of houses and where they're at, and here's an example of house prices. And here's what it is. I live in Duluth, Minnesota. So here's the similar graph. I just grabbed recent house prices off the internet. And so this is some house prices, again, in $100,000. And this is the square foot. And so the upper range of the Duluth market, there are a couple outliers, but the upper range of most of the Duluth market is this $300,000 to $400,000, which is the bottom end of his market. But again, you can look at a general trend here and fit a line to this. I have some additional links to linear regression if you're interested in that. But we're not going to deal too much with linear regression and watching that. So you might want to just go over those videos rather quickly, understand the process of linear regression, and keep going through those. There's some interesting concepts here, especially when he talks about gradient descent, and not just linear regression, but mapping it to a quadratic solution here. He also introduces some basic neural network information, talks about this perceptron and how that uses this sort of non-linear regression in neural networks. So a really quick topic in neural networks. We'll try to get that later on. I love neural networks and did my PhD in neural networks. So we'll try to fit that in later on. But where we really want to focus our attention here is down at the 50th video on nearest neighbor.
As the final method in this unit, I'd like now to talk about K nearest neighbor.
So in K nearest neighbor, we'll be looking at that. So watch that set of videos, the last 5 videos here, and we will be looking at, here's a link to the K nearest neighbor posting in Wikipedia, and we'll be walking through some code here. So I'll post another video walking you through this code and this assignment. So I hope you enjoy that.